1 explained in, I don't know, seconds. Calculus are sussy bakas that studies rate of changes, specifically continuous changes. This calculus thingy consists of 3 main ideas: limits, derivatives, and integral. Let's start with limits. Limit is just asking, what value is a function getting really, really close to as x gets close to some number? Also, the number is mostly in the set of real numbers in calculus. For example, find the limit as x approaches 2 of x squared minus 4 divided by x minus 2. If you try to plug in x equals 2 directly, you get 0 divided by 0, which will give you brain damage. So instead, factor the numerator. X squared minus 4 becomes open parenthesis x minus 2. Close parenthesis. Open parenthesis x plus 2 close parenthesis. Then you can cancel the x minus 2 term. After canceling, you're left with x plus 2. Now plugging in x equals 2 gives 2 plus 2 equals 4. So the limit is 4. For a complex example, consider, find the limit as z approaches 2 plus I of z square minus 2 plus I square, divided by z minus 2 plus I. We do the same trick. Factor the numerator. Z square, 2 plus I. Square becomes z 2 plus I, z plus 2 plus I. Cancel the z 2 plus I term. Then plug in z equals 2 plus I, which gives 2 plus I plus 2 plus I equals 4 plus 2I. So in this case, the limit is a complex number, 4 plus 2I. Now, let's talk about derivatives. Do you guys remember the slope-intercept equation that you learned during grade 6-7? Derivatives are those things, but without the friggin' packet, yo. So, Sussy Leibniz and Newton, aka the creator of calculus, replaced the y value with functions. Now the equation can be used to find the y value at any point on the graph, but now that equation only works on straight lines and when we're dealing with sussy, wavy lines. For example, sin waves. You would be cooked. But the smarty pants during the 17th century found out a way on how to find the slope of a certain point in a line that is not straight. So basically we use the formula that is just the limit of h, as in the distances of 2 points that the line is connected to, is approaching to 0 of the quantity f of x plus h minus f of x divided by h. For example, we want to find the derivative of the point 1. 1 on the parabola y equals x squared. We can plug it in the formula and we'll get 2. Now the last area, integration is just finding the area under the curve of a line. We can find it by identifying where we want to integrate. Let's say we want to integrate the line y equals x squared at the point 0 to 5. We can use the power rule, which is to integrate x to the n, add 1 to the exponent, and then divide by that new exponent. Don't forget to add plus c at the end if it's indefinite, aka it doesn't have something humping on the integral sign. Now we want to find it from 0 to 5. We just put the lower value at the bottom of the integral sign, and the higher value at the top, then replace die with x squared, cause y equals x squared. And then do the formula. We'll get x cubed over 3. Now we plug in the limits, which are just 0 and 5. Now we just substitute x with the limits, and kaboom! It gives us 125 over 3.